Hi, everyone. I hope that everyone is back. I would like to hand it off to Ari to introduce our keynote speaker.
Okay, it took a second before I was allowed to unmute. So, and I see Frauke, so it's great to have her here. So I'm going to read a little bit about her from her bio sketch. It's clear that Frauke has had a great career and is having a great career. She is the chair of statistics and data science for social sciences and humanities at the Ludwig Maximilians University in Munich. She's also the co-director of the Social Data Science Center and a faculty member in the Joint Program in Survey Methodology at the University of Maryland. She is an elected fellow of the American Statistical Association and the 2020 recipient of the Warren Mitofsky Innovators Award of the American Association for Public Opinion Research. In addition to her academic work, Frauke is the founder of the International Program for Survey and Data Science. She's also the co-founder of the Coleridge Initiative. And then she also mentioned that she spent her pandemic years developing the global COVID trends and impact survey. So it's a miracle that she has found the time and has been willing to give the keynote here. So I'm really very grateful that she's doing that, and I'm looking forward to what she has to tell us. We agreed that she can really run her own show, but we have tentatively agreed that she will talk for maybe 45 minutes or so, and then we'll have a Q&A after that. And as always, people can write the questions in the chat, or they can raise a hand or do anything else to get our attention. So Frauke, the floor is yours.
Thank you, Ari. And since this event was planned in DC, I actually found the time to fly here, and now I'm meeting you guys virtually after all. So,
that's terrible, isn't it? Yeah.
Which is too bad, but I thoroughly enjoyed the morning, and in particular, appreciated the panel on the Asian panel that we heard in those details, and I'll try to tie some of what I say back to what was discussed this morning. And if I don't get a chance to say this all, then we'll do this in the discussion. I also want to warn you that I'm shifting gears here. Ari told me I can talk about anything. And so I decided that I'll do a little bit of a different tag on the kind of data we are collecting. Between submitting this title and today, other stuff has happened, and I realized that it suggests maybe an uncertainty of a different kind. This is really more statistical uncertainty and prediction power, less so the global state, but in any case, so that just as a heads up, not to have the wrong expectation here. So what I want to talk about, or discuss with you really afterwards, is a situation that I think our community will find itself in pretty quickly, or maybe some of us already found themselves into that situation, that the data we collect is increasingly used in AI systems, or in systems that do prediction, not just the kind of causal explanations that we do, and or if they aren't directly used for it, that they maybe could be used for it to improve the systems that are currently created. And I'll give 3 examples where I've seen them happening, and some consequences that shake at least the computer science community quite a bit right now, and where I think that the survey community actually can make a great impact in making those kind of predictions in uncertain environments more robust. And I'll talk in the middle part of this talk about sort of the quality of the training data, decision dependencies that happen, and perceived legitimacy. And then I'll give a shout out to some recent developments, some of which we've heard this morning about. So let me start out with the setting in which I want to take us. We have seen increasing efforts by the many statistical offices as well as the UN over time, right, to create out of big data streams indicators that for example, map the sustainable development goals, whether this is the goal of sustainable communities or the goal of no poverty or the goal of decent work and the like. And what we've seen when you look more closely on what kind of data are used to create these, that there's a lot of AI or machine learning involved in both, creating these indicators, but then also subsequently in creating population estimate of the type. But at the same time, similar players or different players, but similar data have been used to do this kind of prediction task, AI supported on the individual level as well, right? So we've worked closely in Europe with both the Institute for Employment Research as well as, the Austrian equivalent of that, and talking to folks in Sweden and Finland, and wherever those data are available, and by those data I mean a possible combination of a survey and administrative data, but certainly administrative data or anything that appears to be there in large quantities and on a regular basis, just like the ones used for the indicators I showed before, that the hope is that one can go beyond the mere explanation or understanding the phenomena, but to help and intervene, for example, to have AI models that help prioritize which people should get support in order to reduce the risk of long-term unemployment. Or if you think of platforms like LinkedIn or others, we certainly are aware that there are algorithms at place that predict which are, likely next clicks, and maybe in the case of job advertisements, in that case, likely next applications to a job posted to an individual. And those usages of AI system in this context have been evaluated by various groups. In some instances, they have found to reduce social inequality, like this paper from Hankat, is pretty interesting in that respect. When it comes to screening, first screening, it helps to have machine do that, not people. But in other cases, like the feedings for advertisement, word is still out and less clear if that's beneficial. But let's stick with the examples for a moment, and I'll come back to the criticism or the fear in a second. Another example from the health context, work done in Chicago. Here too, the goal is, or the situation is, there's a limited set of intervention resources, people available to help HIV patients to stay in prevention programs. And the goal is to predict who would likely be a dropout, and then allocate the resources to those people to keep them in the prevention programs. And the team around Raid Ghani, first in Chicago and now at Carnegie Mellon, have done this in various health contexts, also here with Kansas City, to predict or to break the spiral of incarceration and issue interventions that prioritize mental risk help. So, similar setup, restricted resources, one has to make a decision which part of the population or which individuals should get them and allocate that. And the use of the multiple data sources in making such prediction on an individual level has, of course, an even higher level discussion that ongoing right now, which is that of social scoring. We do know that researchers, countries, other groups, tap into various data sources, sometimes linked at a large scale, like work that Axiom does, and data we use for our research, but increasingly also with the goal to predict indicators that allow, for example, in the justice system to be more efficient, to reduce subjectivity and to keep the effectiveness, right? So in the social justice system, in the criminal justice system, we have seen situations where really the goal was to have fewer inmates by hopefully predicting well, who will not commit a crime again, and then maybe have another sentencing than to those that are likely to recommit a crime, right? So that those are a couple of examples that happened. I didn't make them up, and I would say all of them happened initially with good intentions, you know. And the question though is what happens now, right? That they have happened. And what we see when we look at these systems, that there are several threats to the robustness and how well this whole thing works, that we as survey methodologists are quite familiar with, right? There is a threat to the robustness on the analytic side, and that's what the computer scientists often talk about. You know, they look at the algorithms and they evaluate whether these algorithms are fair, whether, you know, they have similar false positive and false negative rates for the different subgroups. But often overlooked are the decisions that need to be made in this entire data analysis stream. What's even more overlooked is the set of input data that goes into the whole data stream, and also how the output itself is perceived. And I'll touch on each three of them now in a moment. So on the input data side, we know how difficult it can be to have training data for, well, to have data in general be representative for the whole population. In this case, training data for any of these AI algorithms to be representative of the whole population. And no matter what data source it is, whether these are shopping carts or credit card interactions or health records or social media records, we know that people are missing in there. And the question is what to do about that, and how can we solve that? And what the effect of these errors is when models are trained, or predictive models are trained, that then will be used in these AI systems. The imperfectness of the training data has, in some of these applications, already been part of the discussion, in particular in the context of face recognition systems. You might have heard this. There, you know, is a known problem that the training data are, you know, predominantly from people with light skin colors, and the systems work well with detecting faces that look like the training data and not so well with others. And in particular here, as you can see through the different applications on all of the, you know, for all of the players, darker skin tones in females had clearly a lower performance rates in correctly identifying people, right? And so this is a concern that the community has. The community, to my understanding, has so far, you know, really collaborated with experts that know how to draw samples that are representative of the population, right? So there's a wide open field here, but that's sort of one element with real consequences that we see. The other element or threat to the robustness there is on the analysis and computation side. So and I think this is true maybe for us too a little bit. It just, the stakes aren't as high, right? That we don't necessarily always scrutinize the model choices we do, right? Which covariate really goes in our model and which one doesn't, and for which subgroups do we do an additional interaction effect and whatnot. And what you see here is, this is in the context of credit card scoring models with and without marital status and race. And the acceptance rate, meaning so the acceptance for a loan, depending on these model choices, whether it's a small model or the full model, and then you see the performance rates of the scoring algorithm overall in the first panel, and then subdivided by various covariates that were otherwise in the model. And you see that these triple interactions, for example, in education, created quite a difference between males and females when marital status and race is left out, you know, not so much when it's left in. And, you know, I mean, you don't even need to know what happened in the background. When you look at these pictures, you see this is all over the place. And this is a little too sensitive, in particular when these data are used in applications where there isn't strong theory guiding what should go in there. And that is what happens, right? Because often the overarching goal is just to, you know, have strong predictive power and, you know, ideally for all possible groups of combinations. And another choice to be made in these AI algorithms is where to have the cutoff, right? Whom to, like, where's the decision who still gets the support or not? And of course, at its core, the cutoff decision will be made by how many resources are available. But there are, of course, other consideration that could go into place. What we noticed here is that in an application where we've run these kind of models for German job seekers, that we saw quite a bit of difference between different groups, depending on, simple categorization of covariates that go in there, or in this case here, if we decide to support, the most at risk, or those people in the middle ground, where maybe an intervention has the most effect. So one of the debates often is that people are highest at risk maybe also be the least susceptible to the intervention, right? And so the point of these here, and I think these box plots are a little bit easier to read across all the covariate combination again, is that you see accuracy and this F1 score, both measures for sort of, model performance of these machine learning algorithms, again, by subgroups in the population and under these two different policy decisions. So if we do policy decision 1, meaning, let's say the top 20% gets it, and the policy decision 2, where a middle portion of the distribution gets it, then we see, that these performance measure vary quite a bit by the covariate groups, but also each of these dots in the box plot are a single model that we ran that had other computational or other analytic choices that varied. And again, bottom line, the variation is big, and the variation is, depending on these choices made in the model itself, that we often also don't document, right? I mean, we talked earlier about open data and having data available for reproducibility, but here it really gets at the core of sort of decisions made when we form these algorithms. The third threat to robustness is on the outcome side, that in order for these systems to work, and, somehow magically, I think we all got used to credit scoring of sorts, and don't question that as much as the social scoring, right? And I'm a little afraid that 10 years from now, we will have the social scoring be entirely in place everywhere, and it's just as taken for granted, and without this discussion about what data goes in there. And even with the credit scoring, to be honest, I sometimes wonder, the fairness of this for certain subgroups when it is used in that context. But be it as it may, it does only work if the population actually accepts what's happening there, right? And so we recently ran a study where we investigated, with the help of a vignette scenario, or with vignette experiment, fairness perception of the different type of data used in different contexts. For example, the banking context or health context and the like, and to which degree a human is involved in the decision making. We feel that this in the German Internet Panel probability-based longitudinal online survey, maybe all of you know it. Anyway, this was in July of 2021 with about 4,000 respondents. And here's the vignette that we used. For one of the scenarios, a local employment agency has developed a computer program for assigning support measures to job seekers. This program uses data about the person's past periods of employment and unemployment, as well as information about the person available on the internet. A staff member at the employment agency compares this information with that of other job seekers, individuals who have successfully participated in a measure. The employee decides whether the person is to receive a support measure. And so the vignette parameters, varied the context, the action that's taken. For example, assigning support versus, we varied whether this is punitive or supportive actions, the type of data used in that information, and then who makes the decision, right? Whether it's AI or human or a combination. And so what you see here in these descriptive tables is the perceived fairness asked on a scale from 1 to 4, from 1 not fair at all to 4 very fair, that in these various settings, this first one here being the banking setting with the punitive action and an assistive action, and it already shows differences in the distribution of the perceived fairness depending on whether it's the algorithm itself making the decision, humans, or both. And in this case, actually the combination of human and the algorithm seem to be best perceived, which is not the case in the context of job seeking, where there's more concern about algorithms being involved. And again, a different setting in the context of the unemployment support. And here too, for me, the important point is that we do realize that, one model will not fit all of it, right? But I do wonder, and for those social scientists here in the room that read more theory than I do wonder a little bit on sort of what we would expect, perception to change depending on how used we get to these systems. Clearly, as I mentioned before, in the banking system, we have been used to this quite a bit. When you look at these, not descriptively, but in a multivariate context here, an ordinal multi-level regression model on the effect of fairness perception, you do see that each of these parameters do have an effect here, whether it's assistive or punitive, the decider, a human or an algorithm. And then interesting to us, sort of these interactions that we see here, and the fact that, for example, in the banking context, the combination of human and machine was clearly preferred. So to sum this middle part of the threats to robustness up, or the first two, the training data often lack representation. We know this, but we need to be vocal about this, or help, I guess, expand our techniques to mitigate that to this other community. But even when you have these large data streams, we know that there is measurement error in the underlying concepts. And so that too threatens a little bit the requirement for a stable environment, because only in these stable environments the predictions can happen in the way intended. And lastly, that the fairness matrices, I didn't show you that, but when you look at them in detail, they have a trade-off baked in. They can either be very accurate overall or very fair across these groups. It will be societies that have to make the decision on where the effort should be placed. Moving to the last part, there's some recent progress that I feel like our community should be aware of, proud of, and spread the word, just like your beautiful graph here, spreading the information at the CIPHER conference. And one is an extension that we worked on. It was recently published at the beginning of the year in PNAS. Basically, if you will, an extension of weighting adjustment, although it's not really weighting adjustment, right? I mean, it's a common problem to us, or a known problem to us, that you might have a starting source or a databases on which you train your data that don't reflect the population in its entirety, and you would like to make inference for the entire population. Or in the case of medical studies, you collect data in a certain hospital, and that neither covariates nor the outcome reflect the entire population, but that you would like to generalize these results to other hospital, other contexts, right? And so what we often do in our context is, right, that we use propensity score models, or maybe Mr. P, right, and to make these adjustments. And the challenge, though, is that when we do this, when we use propensity scores or use Mr. P, we need to know a lot about our target population. We need to know the distributions and then use that to reweight the data for every target anew, for every new population anew, which can be costly, and in some instances might just not be possible because you don't have the information, right? And so the goal of this method that I want to introduce here is to provide insights, through a more universal format. And we thought of this as sort of a target independent inference, right? Where you have a, propensity score modeling, for example, being a target specific inference, where you at the training time have your unlabeled sample from the source and your unlabeled sample from the target. And at evaluation time, you have the labeled samples from the source. So labeled and unlabeled is computer science speak, if you will. For our community, we probably would call that so that the availability both of the covariates that predict our outcome, and then we need for one of the data, so I mean for the source data, also the outcome itself, to sort of use that relationship, and we use the distribution of the covariates from the target sample to reweight the data from the source. And this target independent inference ideally removes this necessity to have the information of the covariate distribution of your target upfront, and uses only the labeled samples already at the training time. There's a bit of a mathy proof here in the paper. I won't go into detail, but what we were able to show here is that this method basically, building on something called multi-calibration, which has been around for a couple of years now, guarantees this universal adaptability, that, it provides at least as good of a result as a propensity score model would if you had all the information, right? Meaning that we get the same outcome, but we do not always need the same input. This method, multi-calibration, has been used and developed to mitigate bias across subpopulation. If you think of an analogy between the two goals, the fairness goal, that was the context in which multi-calibration was invented, if you will, was to protect subpopulation from being miscalibrated in predictions. And in our case, often in our community, the statistical goal is to ensure unbiasedness for any downstream population that we want to talk about, right? And so the role of the post-processing in multi-calibration is then one that identifies all possible qualified minority subpopulation in the training data, and adjusts then the algorithm so long as that we have equally good prediction for all of the subpopulations. And this way of creating the predictions then, in our case, safeguards for a potential shift in the covariate distribution of our target population. So we tried this out in an empirical evaluation using the US National Health and Nutrition Examination Survey and the US National Health Interview Survey, and then as an outcome variable, the 15-year mortality rate across demographic groups. And what we looked at in the results was the comparison of these various techniques. In short, we found that the imputation with the single multi-calibrated predictor would provide similar performance as would a demographic specific propensity score model. And we also ran some simulations to see sort of the sensitivity of these various model choices, what form of machine learning model is used here, and how the random RF stands for random forest here, and the IPSW is the inverse probability sampling rate, how that was implemented. But by and large, we do see what I said before, that we can perform as good as the propensity score models with this model that needs less input data. So this is, one technique where we were excited that, not only, our community can learn from the computer science community or give something back to them with respect to the input data discussion that I had before, but also here on sort of methods to maybe mitigate some of the problems of biases in the input data by building on technology developed there. And similarly, on the less statistical side, you know, developments, and that was mentioned in one of the talks earlier this morning, you know, the possibility to, you know, gauge a bit information on the offline population. Mita Galagis had this nice overview paper last year, in, you know, talking about this as human social sensing and the possibility to ask people not just about themselves, but about their close environment, and summarizing various research that was done in part by this group here that showed that that can help, you know, mitigate some of these holes. So not just the adjustment type that we had before, because that still requires that you know something about the missing people, but here a way to know that something about the missing people. And I do want to give a shout out to Ari's group that successfully employed this technique in the 2016 election. For those of you who haven't seen the study, I recommend going back and reading this, where the question was not the usually, you know, what would you vote for question, but also to ask, you know, a sense of what would your close social circle of all your social contacts who are likely to vote, what percentage will vote for a candidate, be a question in addition to these individual questions asked. And you know, in we saw that, and in past conferences here discussed, right, that the forecast using those information clearly improved using the social circle questions. And the reason I brought this back up and reminded you guys of this is that we use this in this COVID study that Ari mentioned before, where we asked people if they personally know anyone in their local community who is sick with fever and either a cough or difficulty breathing. So, you know, initially in the pandemic, signals for COVID-like illnesses, and we implemented this question together with the questions on own symptoms in a survey that ran since April of 2020 daily worldwide. So every day a random sample was used by was created by Facebook from active users of the platform. And maybe some of you participate in the survey. If so, thank you. You might have seen on your newsfeed atop the invitation into the survey. And then once you agree to participate in the survey, you will, you know, transported over to a Qualtrics platform, either hosted by Carnegie Mellon University if you filled out the survey in the US, or by Qualtrics, by hosted by University of Maryland if you filled out the survey outside of the US. And then on a daily basis, results were generated from the survey and shared out as APIs for anyone to use. And, you know, with data use agreements, microdata are available as well. What was interesting in sort of the, you know, looking at a year worth of data then across all the country, and this might be very hard to read, and for non-medical readers anyway, it took me a while to get used to these graphs, but the folks that normally do genetic research, they seem to like them quite a bit. So anyway, each row here is a country, and the countries are clustered sort of by developments of the benchmark signal, which was test cases of COVID later on in the pandemic. And you see here, each of these little boxes or columns, if you will, is a month. So this goes from May to December. The development of the cases, and the darker the color is, the higher the intensity of that signal. And you know, these syndromic surveillance systems, they're built because people were worried, or in particular at the beginning of the pandemic, that testing wouldn't happen fast enough, and by the time everyone is in the hospital, it's too late to intervene or too late to shift resources to a particular place. And so the hope was, with the help of this survey via Facebook to have very quickly signals that can produce a better forecast, or, you know, I mean, basically not better forecast than the actual test numbers for subsequent cases, but to fill this void of the first 2 weeks not having enough or good enough data, right? And here we are in this conundrum that I started out with, right? We have a vehicle, we can get the data, in this case, not your usual, you know, big data, machine learning sensor data, but, you know, you have survey data on a daily basis captured at incredibly large scale. I mean, we have by now, I think, surveyed over 100 million people. But this the core problem that we had in all of these applications that I showed before stayed the same here, right? There's data missing on certain people. And of course, the question is, for this particular question, how important is that? Maybe we can see the trends and the development of the trends sufficiently with the kind of population. But what we did see is that the community COVID-like signal, which is the CCLI, the reddish one, overall improved the estimations quite a bit, or the predictions quite a bit, compared to just asking about the person individually, right? So these other attempts to fill in the gaps, maybe through not just through reweighting afterwards, but to smarten up your data collection, clearly has helped. Which gets me to the last point on sort of attempts, right? So the statistical attempts to solve these problems, the survey design and data collection attempts that I just showed to solve these problems. But then also, and that too we had heard this morning a few times, sort of the need and desire to combine different data sources, right? And to use the administrative data sources and together with the survey data and what have you. And I think that would be ideal, you know, in particular when we think of these prediction settings. I think I saw Mick Cooper in the early audience earlier, or at least his name, and I vividly remember when he was talking initially about big data and called them variable poor. That sort of stuck with me. And so this combination is something that certainly would help, you know, these employment agencies, for example, when they make these predictions, right? And so Ari mentioned that in the introduction. We've tried to create environments in which this is possible, one of which is the Coleridge Initiative, where by now several states in the US have decided to put in their wage record data and other confidential microdata so that they can meet each other there and can be useful. But the trick here, I guess, was that it's not just useful for research, but useful for the agencies themselves. For example, for these activities that I mentioned earlier, their desire to predict on an individual level basis what happens. And the only way this seems to work is to create safe environments in which, you know, people who are properly vetted upfront work in a setting where the output is controlled. Well, actually both the input, what kind of data goes in and software is used, but also the output gets screened so that there is no compromise of confidentiality. But it also shows, and that's why it's to me important to bring this up in this context. Remember earlier when I said there are so many decisions on the analytics side, right? Imagine doing that on something that would be more synthetic data, you know, as they're discussed these days often, that would allow to make these data more public. I'm not sure if that is a reasonable way, because then even more decisions have gone in ahead of time, and maybe it's much less possible to scrutinize this entire process. And a similar endeavor, not so much for administrative data, but for the various business and economic data streams. We started now in Germany to create a research environment in which they can be formed. No results yet, no success stories yet there. This is a very recent endeavor, so stay tuned. But the hope is, to form sort of environments in which many of these data streams can come together. And actually, to be honest, not just the data streams, but also the different people, so that our community has the possibility to inform the computer science community somewhat on their efforts. So to summarize here, the data we produce here as survey community, or that we unlock in our efforts to unlock administrative data, are increasingly used for the training of AI systems. I do think there's great potential, but also great risks to society when we do this, and that the users of these AI systems need to know much more about the data generating process, like this community does. And that means for us that we need to have them maybe also as an audience in mind when we communicate our data, its composition, meaning its representativity, but also its, as the computer scientists would say, its label quality, in our case, often referred to as measurement error. And I do think that there is a possibility to jumpstart solutions with borrowed or adapted methodology from social science and survey methodology and statistics in the way that I showed you here. So, so much for my input, and I'm looking forward to a conversation about this.
Great, thanks a lot. This is lots of food for thought. So I haven't seen any questions in the chat yet. So, but I wanted to come back a little. I think you're saying the same thing, right? But at the end of the day, the quality of the data that goes in there is important. And you see this as face recognition, or you see this with lots of other things. And so the social sensing, in that sense, this does seem to be a great addition, because what you're now doing partly is just using the population as monitors, if you like, or observers, right? They're now helping you to fill in the gaps that otherwise you wouldn't have. And I think, of course, this conference and the people at this conference, the business is to collect data and produce data. And I think that's one of the ways that I find may really get us a lot far. And indeed, there was a Singapore example, but of course, the earlier work by Wendy and Myrta on election is another one. So it still seems to me that, and I've always felt that machine learning by itself, it can never be more than part of the story, right? You still have, first of all, you have to understand the data. Secondly, you also have to understand what it actually means, right? And I think the credit card example you had, some of these outcomes don't make any sense, right? So you would think common sense will also help, right? If people blindly trust these algorithms, then of course you're in for a lot of trouble.
Right, and I guess to your last point, I mean, the blindly trusting, I mean, it's easier said than done to not do that, because as they get more complex, I mean, the folks that employ these deep learning algorithms, where you have layers and layers of latent variables, as we would call them, it is much less clear what's going on, right? And so, I mean, clearly there is work going on transparency and whatnot to make sure that one can gain more insight on what is the driver of a particular model. But I do think that again sticks to this narrow part of looking at the algorithm, just like the fairness matrices, without looking at the consequences of missing parts of the population of a certain type in the training data. And I know that I'm preaching to the choir here, that this is clear to this community, but what I guess for me, it's in part an exciting time, because I do think that there's another community that could benefit from the knowledge learned here, but also then would benefit from maybe better or additional data that we produce here that community can use.
Yeah, I think the face recognition is just an example of something that you see in other fields. Like, for example, if you look at genetic data, GWAS is, it's really predominantly done on white people, and then you see immediately that these conclusions for whites don't necessarily then carry over to other races. So you see this in many different applications where we collect a lot of new, innovative, important data, and we do tend to collect it in certain groups, and then we sort of leave out other groups. Exactly right. Yeah. So because when you show this graph about the percent of people you can identify as face recognition, you travel. So if you come into the United States now with global entry, then you don't actually have to show your passport, right? They just look at this camera, it recognizes you and they wave you through. But then when I saw it, then I wondered whether it's only the white males like me who get waved through, and whether everyone else still has to stand in line and show their passport.
Yeah, I mean, I was amazed at that yesterday, but it's a much easier task, right? Because they know who's on the flight, so they're comparing your face to a set of faces that they know need to be there because they have your record beforehand, right? And then it's easy. That's why it goes fast, and that's why it's probably the error rate so little that they're willing to put this up for real. But it's much more scary when you think of, even the smallest error rate in big fishing expedition when you do what you have with the CCTV cameras. And so this really matters.
Yeah. No, that's fine. I'm trying to see if there are comments in the chat. If people have raised hands, I'm not sure I see all the hands.
I see one question here from
Okay. Well, Marco has
yeah. So the question for those that are only on audio, in my experience, computer scientists prefer to let the data speak. Statisticians and other social scientists insist on theory-driven work. How to bridge these two perspectives to ensure an informed choice of models that are explainable and interpretable. So I think there's an increasing realization that the models need to be explainable, interpretable, and the computer science community is trying to create that. In my experience, though, in many of these applications, the hope at first is to just get the best predictive model, and yeah, I would agree. If we were to, if our theories would be good enough, to detect all variables, then I think maybe one could just do this theory driven, but they often aren't. And in particular, they are underdeveloped, I think, when it comes to interaction effects, and that's where these models shine, right? That they just by default look at all these interactions in a way that we wouldn't normally do.
There's actually a chat, but it only went to me by Anna Hartman. Can you ask the question yourself? Otherwise, I'll read it. So she asked, could you show the social network like? Oh yeah, go ahead.
Am I unmuted? Okay, yes, thank Anna. You. Yeah. Thank you. I was just wondering, you had showed a social network type graphic just before your summary, and I missed it.
Oh, okay. Yeah, I can show that again. That was just a group of people that are trying to build such a data environment in Germany.
Oh, okay.
So this is not a scientific network graph. This was just.
Thank you. I wasn't sure what the point was. Okay.
Yeah, thanks. Sorry if I went too fast over that. My apologies. Yeah.
Thank you.
So Marco, you want to?
Okay, I think I'm not muted anymore. So Frauke, I was very intrigued by the results that you showed us about this experiment with the vignettes. I was particularly surprised by how people assessed fairness. And I was wondering whether you collected information or feedback from the respondents so that you can tell whether the algorithm was judged as less fair because you are saying that it will use information on the web. And in the absence of that common sense that Ari was talking about, that may actually imply that there are some red flags that wouldn't count at all if a person with common sense would evaluate them, but they may count a lot because of the algorithm. Do you have a sense of what people thought?
Yeah, so we didn't, no, only in the sense that like looking at the interaction of the various parameters, right? That we would see if web data are used in a certain context by an algorithm and the decision made, is that a bigger issue than if web data weren't included, right? So that in sort of that way, we did not do a follow-up probing on what they perceive those web data to be or how well they think those web data are and whatnot. But that would certainly be an interesting addition for sure. Yeah.
Thank you.
So I think so. As a follow-up to what Marco was asking, so there is sort of social trust also, right? So you could imagine in some cases, people don't trust people, they trust algorithms. In other cases, they don't trust algorithms and they trust people. And I would even suspect that to possibly vary across societies or across groups in society?
Yes, so we did a bit of research on trust and trust on safe data use and whatnot, and that certainly is the case, right? I mean, without a doubt, and in the way that sociologists would expect it, right? That if you are well off in a society, if you're integrated, if you're not at risk, to be treated unfairly or without sufficient lobbying groups, that trust is higher. And so we do these effects, and unfortunately, I mean, that then sort of aligns with available data quality, right? I mean, we know that can be an issue in the data collection to begin with. This can be an issue in consenting of other data sources to be linked. And so then you have a situation in which folks that are maybe at danger of not being looked at, I mean, treated equally fairly, then also contributing fewer data to the AI systems, making any prediction for these subgroups less reliable and less robust, right? And putting them at higher risk going forward. And so that's a spiral that I'm very concerned about.
Yeah. But that, all right, so that might be where the social sensing would help a little bit.
Yeah, it would. I mean, what I think is interesting to think through, if you think about the social sensing in the context of the social scoring, right? Then, well, some other. I mean, it does depend on the application where it could be a little creepy, right? If we feel like it would be increasingly information about others, in particular when. I mean, the way we use, or you guys use, the social sensing as a technology was mostly to get at better point estimates for an aggregate, right? And so if you try to improve sort of the set of training data for an individual level, you would need to know. I mean, I'm not talking about spying on others and reporting on others, all kinds of things. It's still, I mean, in the end, all this is doing is like a gigantic imputation, right? They're trying to like fill in patterns for people that we don't observe enough, right? And so I guess in that sense, it could work. I'm just wondering, how could you report in a strong multivariate fashion about other people without compromising their legitimate privacy concerns, right? I mean, like you wouldn't upload pictures of all the people, right? That seems a little inappropriate, and the same would probably be true by other sort of multivariate reporting. So that is an interesting question to me, how that would. I like the idea of it, but that's why I brought this into this talk, but I'm not entirely sure yet how this would work in a multivariate setting.
Yeah, no, I agree. Yeah, this is getting off to too many anecdotes, but I certainly remember growing up during the Cold War. My father was sort of an important person in the village, and he would get called by the Dutch spy agency to sort of asking him about certain people in the village and their communist sympathy. So there was certainly that. Yes. Gladly, that doesn't happen anymore.
Well,
at least not that I know. No. Yeah. Other questions?
I saw Noemi put her video on.
Yeah,
was that
abundant. Yeah, but she disappeared. So. Well, anyway, so thanks again. I mean, if this, I think this is a lot of food for thought, and also it's such a fluid area. There's so much going on, and I think both positive and negative. I think you pointed out the risk in a number of ways. So it's really great for this group to be exposed to that. So thanks again for taking the time and giving us a very exciting talk. So.
Thank you, Ari, for inviting me.